let's take questions first, and then I want to jump into some of the C-specific stuff, the star and ampersand pointers, dereferencing pointers, all this kind of stuff. And then I want to talk through ODP 205, which is due tomorrow. And then we'll go on to looking at pseudocode again for linked lists in more detail, which will be common for both PA1 and PA2, but I'll be thinking about it in terms of PA2 using these kinds of C statements. So questions, first of all, PA1 or otherwise.
I'm kind of confused when I'm writing like the add deletion on PA1. You're saying like you look for the previous and the current.
Mm-hmm.
Are those fields in the structure?
No, so those are really just integers. So there's two views of the world. There's the famous array. I'm going to skip the valid for now. Let's just look at data next. And then there's the view as a bunch of nodes. And we have the special sentinel node, which points up there. So let's say our list contains a 10, a 17, and a 38. So we know our list looks like this, right? Sentinel points to the first node, which has a 10, that points to a node with 17, points to a node with 38, and 38's pointer is null, or my null, right? So this might be stored in here as for example, for example, that might be what the elements of the array look like. So the sentinel points to index 2, that's our node with a 10, which points to index 5, that's our 17, points to index 3, that's our 38, and it points to null. So it's the end of the list. So when we talk about previous and current, those are integers. And if we look at this loop where we're going through searching for something to delete, we'd start off with something like previous equals sentinel, current equals previous dot next. And the sentinel is always 0. That's never going to change in this. So the effect is previous is equal to 0, current is equal to previous next, that's a 2. Okay, those are locations in this array, right? Logically, we're thinking of it like this is previous and this is current. We're logically thinking of this as a node, this as a node. But they're actually just integers when we get down to the C code. The integer in particular corresponding to a location in our array. So when we say current equals 2, we mean the current node is the one stored at location 2 in our LL array. Okay, it's a node containing a 10 and pointing to node 5. And again, node 5, this is just an integer. We mean the node stored at location 5, which is the node with a value of 17, pointing to node 3, which means pointing to the node stored at location 3, which is a 38, which doesn't point anywhere. It's the end of the list. So there's different levels of different levels of abstraction here. This is what the world looks like in terms of the linked list. This is the actual structure, and in this context, these things are indexes. And in this context, if we want to know what the data value of the current node is, it's something like LL bracket current dot data. Right? Because current is the index in the array, assuming this array is called LL. So we find that element, that's LL bracket current, that's this, and we pick off the data field, that'll give us 10. But logically, current is 2, right? It's this node. We want the data field of this node, that 10. And if we want to find the next field, it's LL bracket current dot next. So now if we say something like current equals LL bracket current dot next, what's that going to do? Well, the code is going to say, okay, current's equal to 2. Let's go to element 2 in our array. That's this box right here. And let's look at the next field. That's a 5. This is going to set current equal to 5. Well, what is 5? It's the index of the node containing a 17. That's this node right here. So the effect of this at an abstract level is it sets current to the next node. Okay, so that's the essence of moving down the list. And we do the same thing with previous, so that's how we have previous current, previous current, previous current. Yeah.
Okay, so I had the exact same question. I was getting so confused on like the previous dot next because I knew it had to have brackets. or
Right,
something,
right.
And I was just, it didn't make sense to me.
Okay.
But now, yeah.
Okay,
that makes a
cool,
lot of
cool.
sense.
Yeah, so this is pseudocode when
Right.
I'm doing something like previous dot next, previous dot current. We're thinking of it abstractly, but in terms of actual C, yeah, use that as an index into the array.
I have a question. So you think we can write LL current dot next equal current with
LL,
current dot next equal current
yeah, you could do that,
already, but I did not. It doesn't work.
but you don't want to do that. Like that.
And
So that's legal syntax, but what we're doing, suppose current is equal to 2, right? So we're looking at this node 10. We're saying take LL current, that's this box here, take the next field and set it equal to current. That's changing this to a 2. So what are we doing? We're taking the pointer of this and we're pointing to ourselves. There's nothing wrong with that technically, but it's not a useful linked list because now if we try to follow this list, we're going to be chasing our tail forever. And if you go into your print or your search or something and it's never coming out, chances are you've got something like this set up somewhere. You've got a pointer that's either pointing to itself or pointing back in the list, and you're just kind of running through. This happens all the time when we start working with trees because we have 2 pointers on each node, and it's really easy to get stuff like this by mistake. Sometimes this is a good thing, though. One version of a list we'll talk about in a little bit is at the end, instead of pointing to null, you can point back to the first node. And then there's never an end of the list. It's just a big, long, circular list. And that simplifies searching and stuff sometimes, because you don't have to deal with the edge case of falling off the end. All right, other questions?
Actually, wait. Okay, never mind, this wouldn't work. I was gonna say, do you want error handling, like you said, it should accept things like I followed by nothing?
Yes.
You want that to be part of our main function?
That's part of your main function, right? So yeah, let's talk a little about main. So somewhere in the beginning, it's got to initialize your linked list. That's a call to your init function. That sets up the valid flags in your array and so on and so forth, and it sets up the Sentinel node. All right, and then we're going to have some kind of loop. Print out a prompt for the user. Read a line of input from the user. And then you're going to use whatever you want to use, a bunch of if statements, a switch statement, an scanf statement, it's up to you. But you want to figure out, for example, this line of input the person typed, does it have the form I followed by a space followed by a number? Okay. Okay, if it does, then you want to add whatever that number is to your linked list by calling your add function. If the input is delete followed by a number, then you want to call your delete function with that number, and so on. If it's S followed by a number, call your search function. And you have some printing to do after these also, right? When you add a number, you want to tell the user if it was successful or not. So you want to check the return value from add. When you delete a number, you want to know if it's successful or not. So you check the return value and you do a message. When you search, you get the return value. It tells you if it was found or not. You want to print a message saying it's found or not. If the input is P, print LL. What's the command for exiting? Is it Q? X. If input is X, we can just return. Otherwise, go back up here. So it's a big loop. That's really all that main is. It's a bunch of calls to other things. And that's typical for main programs. They do some setup. They get some sort of information, in this case something from the user, and then they decide what to call, and they just call other things. And you generally don't have a lot of stuff in here that's doing, list manipulation and LL bracket I dot next and so on and so forth. It's really just sort of deferring to all these other functions that you're writing. So how do we know if the input is, say, I followed by an integer? It's a 224 review.
Did you check the result of scanner?
Exactly. So is the input I followed by a space followed by a number? Well, scanf, put in the string. So I'm assuming our input was stored in an array called input. So put in the string you're looking for. Put in the pattern you want it to match. In this case, it's I followed by a space followed by a %d. And give it the address of a variable to store this number in. And so what value should give us, should scanf return if it found a number? Should give us a 1 because we're asking it to convert one thing and store one thing. So if scanf with that pattern returns exactly a 1, then yes, our input was I followed by a number. And so you can say add LL number and so on. So scanf will do all the hardest part of this for you. Right? You don't need to do A to I, you don't need to look for strings of digits or things like that.
Could you go over how to get the letter?
What do you mean get the letter?
Like the first letter.
Oh, you can look at the first letter by just looking at input bracket 0. That's a character. Okay, it's an element of a character array. So you could say if input bracket 0 equals single quote I, or you could do a switch statement. You could switch on input bracket 0 and have a case single quote I, case single quote D, case single quote P, and so on. Or you can let scanf figure it out for you also. So I prefer to do this, to actually look at the first character and see if it's an I, and then write a bunch of code that I know the purpose of this code is to process an input request. And so if I do my scanf and it comes back with a 0, well, I know they said I, but they didn't say I followed by a number. So I could give them extra help. I could say, you know, insert is I followed by a number or something like that. And if you want to pick up an X or a P, this is an easy way to do it. All right, other questions? Mm-hmm.
Can you define what a node is? Because I feel like I'm confusing it with array elements.
It is an array element.
It is?
So when I use the word node, logically I'm thinking about this. It's a block that contains, for a node of a linked list is a block that contains a piece of data and a pointer to another node. So that's a node of a linked list, but in PA1 it's implemented as an element in this array. So the array is an array of struct nodes, and a struct node is a structure that has 3 fields: data, next, and valid. And we need the valid because we're using an array, and we can't have empty spots in an array. We have to know if it's a meaningful entry or not. But logically it's just this box with an arrow on the bottom and a number on the top. That is not an insignificant question, by the way. Right? It's this constant dance between abstract and code that we need to sort of get comfortable with. Because we can't really talk about and develop and debug programs involving data structures if we're always thinking about C code. If we're always thinking about LL bracket I dot next equals such. We need to be able to think of it logically or abstractly. And when we can talk about things like this, we can talk about all kinds of complex data structures. And it's nothing to have a node in a linked list where we have a number and we have pointer to another linked list and a pointer to a following node, and this might be, you know, its own type of linked list. And so we have a linked list where the data part is actually an integer and a sentinel node pointing to another linked list. And the code for this, you can imagine, gets fairly convoluted because it's node dot list piece dot something else, right? But logically it's nice and clean, right? So we would think about it, we'd figure out the algorithms, we'd design the program at this level, and then you write the code to actually implement it. And if you modularize it, it's fairly straightforward, and if you modularize it in a nice language like Java, it's completely trivial. And building things like this is no harder than making an array of integers. We just say the element is, you know, my linked list or something instead of integers. You had your hand up first?
Yeah. How complex should be the search function? Because I have it returning 5 values.
Yeah, we're returning 5 values.
Yeah. Ish.
What are the values you're returning?
The tracker to see how large the thing is, to see if the number exists, the location to add or remove, the next location for the actual pointer, and then the actual structure.
Okay.
That way you can modularize it for both the add and delete.
Yeah, if you want to use that in your add and your delete, that makes sense. The search, just for the sake of searching, really needs to take a list and a number as inputs, and it returns basically a flag, found or not found. But if you're trying to generalize that so you can use it for add and delete, yeah, you also want to get back the previous and the current and maybe some additional flags. And it's up to you what works best for you. If that is making sense and it's making it logical for you, then that's great. if you don't want to get into functions and passing things like that in special cases, and you just want to hardwire it, 3 or 4 times, that's fine too. All right, you had a question?
Yeah, so you think the index within the brackets, right, is a node, which is an index of the linked list? Is that
So what are we talking about?
what you just explained to him answering his question was trying to get you to
About this down here?
yeah, there's a couple of things like, for example, if you have LL index dot next, right? That index is just it's the node itself, which is just
So yeah, so LL bracket index dot next is just an integer.
yeah.
It's the integer which is itself an index of another node.
Yeah. But okay, so example for your LL current, right? Current is just an index of linked list.
So current is an index in the array, right? Is what we're thinking of as the node. LL bracket current is basically this node,
Right.
right? It's exactly an element of this array, which means it's a struct node in terms of C, right? And this is a struct node.
That node is called current.
Yeah, so I call this a node, but in reality it's a struct node. It's a compound variable that has a data piece and a next piece, and also has a valid piece. Make sense? More sense? All right.
I noticed that in the program, sort of instructions in PA1, you kind of initialize everything. So, for example, for like the delete node, I think it was,
Mhm.
for several of them, you initialize them to returns, or to have to return an integer. For my specific program, it is more convenient if I do void and not return anything and just pass around pointers. Do you
So you're gonna pass so for search, for example, it's
Yeah.
gotta tell you if it found it, so you're passing a variable, and it's gonna set that to be 1 if it found it and 0 if it didn't.
and it doesn't return anything, just sets the pointer?
You can do that. Is there a reason why that's easier than just returning a value?
Yeah, because I'm just sort of cycling between functions. I'm not necessarily controlling it from the main program. I'm just doing it between functions. So from function to function to function.
Okay.
So I like a main function that I guess deals with the user interface and then kind of does the rest of it.
Mm-hmm.
So if I return something, then I don't know. Maybe I just haven't figured it out. If I return a number, where would it go if I'm going from a function to another function and I return it? The function that I was at earlier, it doesn't continue executing. If I branch off to another function, for example.
Well, you should return from functions, right? So let's go back to main, for example.
My main is really short.
Okay, good. Oh, really? What are your 3 lines?
Just init and then start.
Okay.
And then start is like the thing that deals with the user.
Okay. So here's one way you could write start, right? So you could say, get input. All right, print a prompt, get input.
And you should probably know that I don't have a while loop. After anything executes, it just goes back to the start function.
How does it go back to the start function?
At the end of the function, I tell it to go back to the start function.
So you call start from inside start?
I call start from a different, so at the end of, let's say I print the list.
Mm-hmm.
At the end of the list, or at the end of the print function, I just tell it to go back to start and then ask the user,
How do you go back to start? Do you say start, parenthesis, parenthesis?
Yeah, I just say start and then I pass the pointer of the list.
Okay, that'll work for a while, but it's going to be chewing up resources. Okay, so that's what we call a recursive call, basically. Because ultimately, start is calling itself, right? Start calls print, and print does something, and that eventually calls start again. And that's going to take up more and more memory the longer this program runs. And theoretically, if the program never exits, eventually you'll run out of memory. And we will be doing recursive stuff in a few weeks, and it'll be essential to do recursive stuff. But you don't want to do that unless there's a really good reason, and you know that in some reasonable amount of time you're going to unwind all of those calls. So that's a funner way to program, but you probably want to do it with a while loop. And we can talk about it offline if you want, and talk about reasons to do that or not do that. But it's not usually considered a desirable thing to do unless there's a really good reason for it.
Would it work for this case since the node's only 100 elements long?
But I might put in 10 million add and delete requests, and each one of those is going to nest deeper and deeper in the stack. And what happens is you run out of stack space. If you've done engineering 270, that would only work for like 32 times, and then you'd be out of call space. So on inside start, so you get your input and check to see if it's I followed by a number, and let's assume it is, right? scanf comes back with a 1, so you can do something like, result equals add LL comma number. And then check the result from the add function, and if it's 0, print fail, otherwise print success. Now if you're passing result in here like that should work fine. But if it feels like this is easier than this, I'd like to see what you're doing and talk about it, because there might be something else. So I wouldn't take off points for this per se. Okay, my concern is that maybe you're doing something else that would cost points, and it's showing up as you're doing this. So we should probably look at your code and make sure there's nothing really funny going on. All right, other questions? This is good. It's so much better just doing questions here instead of standing up here talking for an hour. Yeah.
You said ODP 205.
Say what?
ODP 205.
Yeah, I'm still going to talk about it. Yeah.
I feel kind of silly, but in my delete node,
Mm-hmm.
I have current does not equal my null.
Okay.
Do I just add another loop for the edge case of the number that I'm searching for if it is the last item?
I don't think it's an edge case if it's the last item.
Well, maybe I'm doing it wrong. That's how after searching for the number on the list, I then enter into a while current does not equal my null, and then I search if the current data is the number, then go through the delete process.
Okay. Are you keeping track of a previous as well as a current? Okay. So if you're deleting the 20, what do we do here? We say basically previous next equals current next, right? So it skips over. Okay, so if we Instead, this is previous and this is current. And we want to delete the 30. How should we delete the 30? You want to just set previous next equal to null, right?
Yeah, yeah.
But that's, null is also current dot next.
Yeah.
So,
I'm saying while I'm traversing through the list,
right.
looking, it'll pick it out without looking at the 30. Is that
How does it pick it out without looking at the 30?
because I moved to the current dot next,
Okay.
and then it loops back into the while loop while current dot next is not equal null. Before looking at that 30, it kicks it out because it equals null.
Oh, okay. So initialize your previous and current, right? While current is not equal to null, right? As opposed to while current dot next. If current data equals number, then I think you can just do previous next equals current dot next. I think that'll work even if you go all the way down to the last node. So if you get down to the last node, current's not null, current data is 30, that's equal to the thing you're trying to delete. So it'll set previous next, that's this node's next, equal to current next, which is null. That pops a null in here, which is exactly how you delete the 30.
Maybe there's something else now. I'll look at it again.
Okay.
That's exactly what I have.
Okay.
I'll figure it out.
Yeah, we can whiteboard it later if you want. Yeah.
Can you run a variable as a function if the stored value of the variable is the same as the name of your function?
Not directly.
Because I was thinking about our pseudocode if statements where we're using a scanf and then checking for a string and then number.
Mm-hmm.
And we know that we have BSPX and I as like inputs.
Yeah.
And we stored that I as a string. And we knew, like, named all of our functions to deal with those after the, I.
Right,
SD.
right.
Would
So
you then be able to run it? Or?
you can do things like that. You could make a structure that somehow had, the letter I and then a pointer to the function, and you can execute like that. But it gets pretty convoluted pretty quickly. And a switch statement essentially does that. Right? If you switch on this, if it's an I, call this. If it's a D, call that. It's not as elegant, but it's fewer headaches for this. But there are ways to do that, and that gets you into a lot of interesting stuff. Because now you can make like an array of functions and.
I was trying to thought experiment how to do that without if statements.
Yeah, it can be done.
I mean, you still have to have one. In that case, you have to have one if statement to make sure that any of the input values are actual functions, or else you start erroring. Right.
Right.
But that's less than 4.
Yeah, and it's actually more efficient to do what you're describing, but more confusing to set it up. But yeah, if you want to look at that, come by office sometime and we can play with it.
Yeah, but you're saying it's not functionally different than switch statements?
It's functionally different. Functionally, no, it's the same in the end. It's more code to be executed in a switch, but it doesn't really matter. Because we're limited by user input speed in this case, so but yeah, that's an interesting area. All right, let me jump into the ODP. So we're making a function here which accepts a pointer to a struct node. And this argument is not intended to be an array of struct nodes. So So this is not a piece of PA1 either. This is an exercise in playing with stars and ampersands and stuff. So the behavior of this function is really, really simple to explain. It's a function called set. It takes a pointer to a struct node. And a struct node here has only two fields, a data field and a next field. Okay? What your set function should do is double the data field and then set the next field to null. Okay? It's two assignment statements. So you have to be able to read the data field, and then you have to be able to set the next field. And yeah, that's pretty much all it says. So what does this look like in code? Did I actually name this thing? Nope, so we'll just call it argument. And it doesn't have a return value. All right, so argument is a pointer to a struct node. So this will all be comments. Arg is a pointer to a struct node. So when you have a pointer, how do you actually get the thing that it's pointing to?
Reference operator.
Say again?
The dereference operator.
The dereference operator, which is?
Like a star.
Yeah, it's a star. So I shouldn't have put that, it'll look confusing. Okay, so arg is a pointer to a struct node. Star arg is the struct node that arg points to. And a struct node has two fields. It has a field called data and it has a field called next. So let me put in some parentheses. Star arg dot data is that struct node's data field. And star arg dot next is that struct node's next field. I'm going to say yes, and it's not going to matter in a little bit. But I'm definitely going to leave them in for now. All right, so how would we write a statement in C that doubles the struct node's data field? Someone take a shot.
Star r dot data equals 2 times star r dot data.
Perfect. That's all you got to do. Take the thing that arg points to, grab the data field, multiply by 2, write that into the data field of the thing that arg points to. And then to set the next field to null, it's just that. So we're doing kind of the same thing like we did in the beginning of our initialize ODP. We're setting the data next field in a struct node, but we're no longer taking the argument as being an index in an array, right? There's no array anywhere in sight here. This is just a struct node stored somewhere in memory. You don't have to worry about where that struct node is. You can believe that argument is pointing to a struct node.
Why do the assignment to null says that it makes a pointer for an integer without the pass?
Make sure when you define your struct node that the next field is a pointer to a struct node, not an int. It doesn't think it is.
It's exactly like that.
And he definitely recompiled it? Can you show me right after class? Okay, cool. Yeah, it should like that. All right, so let me give you the fancy shorthand. So struct node so it has an integer data and a struct node star. Next. And suppose this is our previous node. So previous is now a struct node star. It's not an integer anymore. It's a pointer to a struct node. And suppose previous is pointing to this node here, and this is a 5. And this is pointing to a node that has a 10. Suppose we wanted to find out what the data value is of the node that comes after previous. So we could do something like this. So struct node pointer next, and we could say next equals thing pointed to by previous dot next. Let me stick with current. I don't want to have too many nexts. So struct node current. Current's a pointer to a struct node. I'll set current equal to what the previous node is pointing to's next field. And then I could say, you know, data, next data equals the thing that the current points to dot data. So here's previous. I set current to be the thing that previous points to, and then I say look at the thing current points to, pick up the data field, and I'm going to call that next data. So these two expressions would get me to the 10. Now if I wanted to do this in one statement without having this temporary variable, here's what it looks like. Next data equals, well, current is actually star previous dot next. That's the address of the current node. So I can take the thing that points to, and I can pick off the data field. That's a mess. We don't want to write that. Okay? You don't want to be writing code like that. So there's a shorthand. So variable, thing that it points to dot field, we can write this as variable and then this symbol and field. So variable arrow field is a shorthand for the thing that variable points to. Take the field off of that. So we could have written this current statement instead as current equals previous arrow next. And then we could have written this second statement as next data equals current arrow data. And this is a whole lot nicer to work with than that. If we know previous is pointing to a struct node, this says I want the next field of whatever previous points to. And so it's kind of like using a dot, previous dot next. Except if previous is a pointer, we use previous arrow next. Here we could say current dot data, but since current is a pointer, we say current arrow data. And it means this gibberish, thing pointed to by current, take the data field, but we're rarely going to think of this. we're going to start just thinking of this. This is the data field of whatever current points to. And the main advantage of this is if we want to write something like this in a single statement, it would look like this: previous, arrow next, arrow data. So take previous, take what it points to, and take the data field of that. And we can start chaining these things together and doing all sorts of nested dereferencing, and it just sort of lays out in a nice linear. You had your hand up?
Does it always dereference from left to right?
Yes.
Does it have to be in the left hand or can it be in the right hand as well?
What do you mean, the left hand or the right hand?
Like, did you say the previous arrow next is equals?
Yes, you can do that. Yeah, so you could say previous arrow data equals 5 or whatever. Yeah.
Just to be clear, is that just a hyphen and then a right?
It's just a hyphen followed by a greater than sign. And this is probably the only new piece of the language that you encounter anywhere in this 200 level programming sequence. There's function calls, there's malloc, there's free, there's Unix things, and so on and so forth. But you've seen basically all of C that you need to know, except possibly for this, and maybe you see it in 121. This is the only sort of new piece, is this arrow notion. And it's really just a shorthand for *var dot field. But it makes life so much easier because we can chain these things together. And this is just kind of distracting and disturbing. So when you're writing ODP 205, right, and it's really just 2 lines of code, go ahead and write it, get your points, but try to write it with the arrow notation, right? It's a really good practice for it. If you don't get the arrow notation to work, go back and write it like this and make sure your last assessment is 100%, okay? But you can use it to practice this kind of thing, and the code comes out a little more elegant with the arrows. And we can look at that tomorrow. All right, cool. So we'll play more with this stuff tomorrow. We'll play with some of it in GDB, and then we'll look at pseudocode for linked lists using these kinds of notions. Yeah. Oh, you want null, not my null. For PA1. Yeah, if that doesn't work, let me know, but null is actually a pointer. All right. Is there a unique name for that arrow operator? I don't know what it's called. Okay. It's good. Find out and let the class know. That'd be interesting. Are there
Search algorithms? I've never been able to find it. I looked on Google for anything besides linear search algorithms.
That's really all there is linear.
That's what I thought.
Yeah.
Big trees that.
No, it's basically just an array. There's not a whole lot you can do.
Okay.
Now, if it's sorted, you can try to do a high-low.
Okay.
But you gotta, if you decide it's in the second half of the list, you gotta have a way to get to the middle of that. And that'll take us to trees, basically.
Right. So I was trying to figure out a way, and I couldn't think of any way besides making more
That's really
things
just
pointing
linear.
at them.
Yeah, exactly.
Okay.
So my release node function is like 1 line.
Okay.
And I wasn't sure like if I was missing something, if I misunderstood the prompt. Because the way I had
No,
understood
it's a
it
one-line
is-
function.
Oh, okay.
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 Set valid to 0 and return.
Okay.
Yeah.
Awesome, thank you.
Okay.
Just on a general idea, is this kind of what you're looking for part of the delete function?
Let's see. So previous and current would actually be integers.
Integers
Instead of struct nodes. But maybe you could do them like struct nodes, but let's see. So search your list for
I thought that part felt a little because I had no idea if you can assign.
You could do that, but that statement would be a little different. So you're saying current equals previous dot next.
You just you the whole time.
By the way, thank you for your advice on my previous.
Oh, yeah, definitely. Since previous dot next is an integer, an index into your array, this would actually be something like current equals a bracket previous dot next. Yeah. And then if exist is 0.
And then I probably have to reassign stuff like that.
Yeah.
And that.
Right. Yeah, that's fine, and that would be a bracket current dot next.
Okay.
Yeah. You can do that, or the other option is just make those integers. Same thing in the end, whichever way makes more sense to you.
Did you say this looks okay, or does this
Let's see, current dot next is
current dot next is whatever a current dot next is.
okay, so that's an integer. Yeah, so
I'm still thinking of pseudocode.
right. So current next is an integer, so that would be previous next equals
a bracket current dot next.
let's see, so this is just a different mindset from where I've been, so so current is an actual node, current next is an integer.
Yeah, I guess I can show it to you. Yeah, because that's good because you're wrong. It's kind of hard.
I think that's right. Yeah, I think that's right.
That part is right.
I think so. That actually sets the next field of the previous node to be
You can always find out why
next.
and compile it. And
Yeah,
test it.
and test it. Yeah, but I think that's correct.
Okay.
Yeah.
Oh shit.
I forgot to stop recording after the last class, so if anybody said anything embarrassing during